Hello everyone, just going to go over a couple of concepts here. The first one is we're just going to find the midpoint between these 2 points right here. We've got J 5, 7 and K 3, 9. So I just laid out the midpoint formula. You're going to have to memorize this. So it's just sort of the average between each of the two coordinates, the X and the Y. So the first thing I'm going to do is I'm just going to substitute the values in. So xj means the x value of point j. So you can see right there, that's 5. So let's just write in that. So we get 5 plus the x value of point k, which is 3, divided by 2. And we do the same for the y. So 7 plus 9 over 2. And then we just work these out separately. So 5 plus 3 is 8. Still divide by 2. 7 plus 9 is 16. Divide by 2. And we get the midpoint between j and k is 4, 8. Okay, and that's it. That's the first part. Now the next thing we're going to do is just find the equation of this line. So in order to do that, we're going to use our new kind of special way of finding the equation of a line. So we're going to use point slope form. So we get y1, or rather y minus y1 equals m times x minus x1. And then we just think about what it is that we're missing. So I'm just going to use red to show what we're missing. Y is a variable. It stands in for any point. So we don't need anything there. So x and y are taken care of. But y1 is the y value of a specific point. So why don't we just use point j for that? So that's going to be 5, 7. You could use the other point as well. So now we know what y1 is and what x1 is, and we're just missing m. But luckily, we know how to find m. M is equal to rise over run, which you can find out by y2 minus y1 over x2 minus x1, just like that. And we'll use point j and k to find those. So we'll use k as 0.2 and j as 0.1. And so we have the y value of k first. So that's 9 minus the y value of j, which is 7, over the x value of k, which is 3, minus the x value of j, which is 5. And we end up with 2 over minus 2, which is the same as minus 1. Okay, let's start a new page here. So what did we have? We had y minus y1 is equal to m times x minus x1. And we were using point j, which was 5, 7. And we found the slope is equal to minus 1. So now we just plug in that information. So I'm going to leave the stuff that stays the same as blue, and we'll write in red for the new stuff. So we've got minus 7 and plus 5. Oh, sorry, minus 5 there. Minus 5. And the slope of minus 1. Now this is the equation of the line. When you plug in an x value, it will give you the correct y value. But it does look quite messy. So let's just clean this up. We'll use purple as our cleanup color. Okay, so we'll just distribute that. So we get minus x now, plus 5, and we'll leave everything on the other side the same for now. So y minus 7. And we'll put it into, I don't know, y equals mx plus b form. You can use standard form if you want, depending on what the question's asking you. And so when we do that, we get y equals, we've still got minus x plus 5. And then we'll use purple again because we're just cleaning things up. We'll add 7 to both sides. And in the end, we get y equals minus x plus 12. And there you go. There's the equation of the line. Like I said, this is also the equation of the line. This is just a nicer way of writing that. Okay, so now the last thing that we're supposed to do here, so we've done that, is find the length of that line segment. Okay, so I'm just going to rewrite the points here. So I got j, which was 5, 7. And we had k, which was 3, 9. So 3, 9. And now we're just going to write out the formula for finding the length. So the length is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared, which is basically just Pythagorean theorem. So now we can just plug in what we know. Once again, I'll use red for plugging in. So I'm going to use this as 0.2 again, and this is 0.1. But you could do the other. You just have to stay consistent. So if this is x1, that has to be y1 as well. Okay, that's all there really is to it. So let's plug this stuff in. So we've got 3 minus 5, and over here we've got 9 minus 7. And since everything else is the same, I'll just put that back in as blue. That. And now we just work it out. So what's going to change here? 3 minus 5 is minus 2. And 9 minus 7 is 2. And what do we got here? So plus there. Don't forget that when you square a negative number, it makes it a positive number. So what we're going to get now is 4 and 4. And over here, just plus. And L equals the square root of 4 plus 4. So L equals the square root of 8, which is whatever it is. You can leave it as the square root of 8, or you can write it in a different way. Depending on the question, it might be better to write it as a decimal. Okay, so that's basically all we have left here. So this could be written as 2.83, for example. And that's basically all three of the major parts that you'll need to know for doing analytic geometry. You can find the equation of a line, and you can find the length of a line segment. You can find the midpoint in a line segment, then you're going to be fine. Okay,